Guess who? That's right, it's Mrs. Hoekstra. This is Module 3, Lesson 13, Inequalities. I'm on page 102 of our book. The essential question today, what are the different inequality signs and what do they mean? All right, what are the signs and what do they mean? And I'm talking more in context, not just, oh, this is the is greater than sign. All right, we're talking more about in a context problem. All right, so do you see that it says this opening exercise here? Well, I'm going to jump then over to page 103, all right, because we're going to do this part here in class. All right, I'll just write that down, in class. So we'll jump over to page 103 where it says example 1. All right, evaluating inequalities, finding a solution. All right, so we've got this little number or a sentence here, and we're going to convert it over. The sum, oh, that tells me to add, of 2 consecutive odd integers. We've seen that a lot in this book, right? Then check out the next 3 words. Is more than. I want you to underline, highlight, do something so that that jumps out at you. This isn't just a is. Is would be an equal sign. This is a is more than, which tells me I'm going to have an inequality. Is more than is my cue. It's a greater than. And then I've got my negative 12. Okay, so let's write different things that possibly could make this true. All right, let's just write down, for example, number 1, I could say 2 consecutive odd integers. 3 is an odd integer, plus the next consecutive would be 5. Is more than, is greater than negative 12. That is a true statement, right? 8 is greater than negative 12. That works. Let's think of another one. Let's try negative 1. That's an odd number. Plus another negative, the next consecutive, I'm going to say is negative 3. I'm going to do with those. That is more than negative 12, right? Because that really becomes negative 4. Negative 4 is greater than negative 12. All right, let's try one more. Let's see. How about if I did 7 plus 5, right? 7 plus 5 is more than negative 12, right? Because that becomes positive 12. Positive 12 is greater than negative 12, and that's a true statement. All right, so all those are true statements. Any of those could make this particular sentence true. All right, now it says, write an inequality that can be used to find the smallest possible value, right? So now we're going to write it using some variables. So let's define our first odd integer. We'll call it x, right? I'm not very original. We'll just call it x. We could use n. You could use whatever. Our second odd integer has to be the next consecutive one from x. We have done this before. So the very next odd number is going to be x plus 2, right? Because if I did x plus 1, it would just be the next integer, but I need the next odd integer. All right, so there we go. Now let's write a statement here to make this true. So we're going to have x plus 2, right? There's my first number, my second number, and then I know is more than, there's my inequality, negative 12. Could I simplify this? Sure. I could kind of clean this up. I have 1x plus 1x, right? Those two there, I can combine them and I get 2x plus 2 is more than negative 12. All right, well, what if I made some moves, right? If I do some of those if-then moves and solve this and try to figure out what that odd number is. So if I'm adding 2, I could subtract 2 from both sides. Now positive 2, negative 2, they cancel out, and I'm left with 2x is greater than, the symbol does not change, okay, because I'm not dealing with any negatives or anything. I should say dividing or multiplying by negatives. And then negative 12 plus negative 2 gives me what? Negative 14. All right, well, I am multiplying. If I am multiplying both sides by 2, I could divide both sides by 2. 2 is a positive, so my inequality sign is not going to change directions. And I have x is greater than negative 14. All right, so my first integer, right? The first integer we said was x, and we know that x has to be greater than negative 7. Okay, what is my second integer? The second integer, right, we said was x plus 2. In other words, it is negative 7 plus 2, which we know is negative 5. So we know that that one is negative 5. I probably shouldn't put that inequality there. We'll say that our first integer was negative 7, and we'll say that the second one was negative 5. Okay, so those are my two integers that make this true. If I put negative 7, let's even check it. If I put negative 7 plus negative 5, right? Negative 7 plus negative 5, and negative 12. This is negative 12 is greater than negative 12. That's not true. Uh-oh. We've got a problem here, don't we? So what would be my next odd integer that's going to make that true? Negative 7 and negative 9 would make that true. Negative 7 plus negative 9, right? Now I'm going to have a true statement. I'm going to have to figure out my mistake. I'm going to come back to this. I'm going to put a question mark here. We'll figure this out when we come back to class. Something's up. I got to figure that out. But for now, I'm going to move on to page 104. All right. So Connor went to the county fair with $22.50 in his pocket. So he cannot spend more than that, right? That's all the cash he has. He bought a hot dog and drink for $3.75 and then wanted to spend the rest of his money on tickets, which cost $1.25 each. Okay, write an inequality to represent the total spent where R is the number of tickets purchased. Well, remember, he bought a hot dog and drink for $3.75. And he's going to buy tickets that are $1.25 each, and we know that a ticket is the letter R, and he can spend no more than $22.50, which means this is going to be less than or equal to, right? He can spend no more than $22.50. Why am I writing 50? $22.50. There we go. So that's how we figured that one out, right? And you're like, well, how do you know it was less than or equal to? He can't spend more than $22.50. It's got to be that or less. He can spend less and pocket the change, right? He asks his parents for money and he pockets the rest. I know you guys do that. All right, let's see. Connor wants to use his inequality to determine whether he can purchase 10 tickets. So can he at least have 10 tickets? Well, let's find out. So we have what? $3.35 plus the $1.25 times the 10 tickets that he's going to possibly purchase. And we know that this is going to be less than or equal to $22.50. Let's see if that's true. So $3.35 doesn't change. When I multiply $1.25 times 10, I get $12.50. And is that less than or equal to $22.50? Well, let's add these up. $3.35 and $12.50, that gives me what? $15.85 is less than or equal to $22.50. That is a true statement, so yes, he can buy 10 tickets, right? He can buy 10 tickets. He's even going to have money left over, right? Yeah. What is the maximum number of tickets he could get? All right, so now let's just solve this for R. Let's figure out, well, what if he doesn't want to do 10? What if he wants to do more? How many more could he do? So let's take the $3.35 plus the $1.25 times the number of tickets is less than or equal to $22.50 and solve for R. You're going to solve this just like you would if there was an equal sign, okay? So we're going to subtract $3.35 from both sides because it's currently being added, or it's a positive number, however you want to think of that. And let's subtract that over. These two are going to cancel out, and I'm left with $1.25R. Oops, put the decimal in the right place there, Mrs. Hoekstra. $1.25R is less than or equal to, what's $22.50 minus $3.35? It's $18.75. Okay, now I'm going to take this. Since I'm currently multiplying by $1.25, I'm going to divide by $1.25. And I find out that R is less than or equal to 15. So he can ride no more than 15, or purchase no more than 15 tickets. He can purchase no more than 15 tickets. Okay? If he gets 16, he doesn't have enough money. If he buys 14 tickets, he's got $1.25 left over, right? It works. All right, write and solve an inequality to represent the following problem. I'm going to help you guys get this started, but then I'm going to have you figure this out. On a particular airline, checked bags can weigh no more than 50 pounds. All right, I do this every time my daughter leaves for college. We have to make sure it weighs 50 or less, right? No more than 50 pounds. So it can be 50, it can be 49, it can be 48, it can be 25, right? Just cannot weigh 51, 52, 53. Sally packed 32 pounds of clothes and 5 identical gifts, right? We have 32 pounds of clothes and 5 identical gifts in a suitcase. And the suitcase weighs 8 pounds, right? Because the suitcase itself has weight. So we want to know how much can each of those gifts weigh if she is going to make it. So I'm going to help you guys get this started. You're going to keep track of the clothes. This is me and my crazy hieroglyphics. Clothes plus the gifts plus the bag. And it has to all be less than or equal to 50 pounds. All right, I've set it up. I want you guys to hit pause. And I want you to try to solve and figure out how much each gift is weighed. All right, hit pause. All right, so there's my work. I have 32 for the clothes, 5G for the gifts, and 8 for the bag. And it all is less than or equal to 50. I added the 32 and the 8 and got 40. So I have 40 plus 5G is less than or equal to 50. Then I use my if-then moves. If I'm adding 40 to both sides, I'll subtract both 40 from both sides. And so now I have 5G is less than or equal to 10. I'm going to divide both sides by 5, and I find out G is less than or equal to 2. So in other words, the gifts can weigh no more than 2 pounds each. They can be 2, they can be 1.5, they could be 1 3/4. They just cannot be 2.1. Right? It's going to put us overweight. And then they charge you like $100, even if you're only a pound over. Trust me, I know. All right, that is all I have for us today on here. We're going to do some of these things in class. We're going to find out what my problem was on that other one, and I will see you all later.